Last examples for this idea of combinations or putting together functions using arithmetic of addition, subtraction, multiplication, and division involves these two functions here. So in the earlier example, the two functions we looked at, straight line linear function and the quadratic function, the domain had no restrictions. Nothing had to be kicked out, negative infinity to positive infinity, so life was pretty straightforward. Domains for the functions we created using the math were negative infinity to positive infinity, except for that last one, that where we created the fraction with the denominator. In this example, we're going to be looking at two functions, both of which involve square roots. So there is going to be limitations to the domains of both of these functions, which has implications for the domains of the functions that we will create. So first, let's create these functions, and then let's look at the domains. So the first one, f of x plus g of x. So f of x plus g of x. So this is going to be square root x minus 3 plus square root x plus 1. Nothing much to be done there. So this is f plus g of x. Not a very pretty looking function, but that's what it looks like. Now, let's look at the next one. I'm going to skip the multiplication and the subtraction. I think that you get the idea at this point. I'm here more concerned about the implications for domain. So f divided by g of x, this is going to be f of x over g of x. And so this is going to be square root x minus 3 divided by square root x plus 1. And then here, this we're going to divide, but now we're going to g of x divided by f of x. So we're going to switch which function's in our numerator, which function is in our denominator. So for this one, we have square root x plus 1 over square root x minus 3. So here are the new functions that we've created. This, and this. Now let's take a look at the domains. So we need to consider the domains of f of x and g of x. So for f of x, the domain of f of x, what's under the square root here has to be bigger than or equal to 0. So for f of x, x minus 3 has to be greater than or equal to 0. Add 3 to both sides, and we get x has to be greater or equal to 3. And this is going to be 3 to infinity. Now let's take, sorry about that. Let's take a look at our g of x. For g of x, we have x plus 1. What's under our, I just got this weird message on my computer screen. What's under the x plus 1 to be greater than or equal to 0. So now to solve, we subtract 1 from both sides. X has to be greater than or equal to -1. And in interval notation, we have -1 to infinity. So there are our domains for f of x and g of x. For the domain for this function here we've created has to be what's in both. So if something is kicked out of one of these domains, it has to be kicked out of here. The domain for this can only include what's allowed for both of these, the intersection of these. So in this case, I think it can be helpful to look at, so the domain, a little graph, the domain of f plus g of x. So the domain for this function we've created, let's make a number line here. -1, 0, 1, 2, 3, and it goes on, and it goes on. So there's our number line. So f of x says it has to be 3 to infinity. So for f of x, there's our domain. So this is our f of x. For our g of x, it says -1 to infinity. So g of x is back here, okay? For our f plus g, we can't include these x values back here because they don't work for f of x. So for g of x, we are limited to the intersection here, which would be this here, the intersection. So our domain is going to be the 3 to infinity. It's going to be the same as this one because we can only include these values. We can't include anything from -1 to the 3. We can't include anything there. Now let's take a look at the implications of this for this function here. This function here, we've already looked at the domains of f of x and g of x and their intersection. So we know we're starting from here, right? We know that this should be the domain that works for here. Question is are there any other considerations now? And there are, because we've created this denominator here of x plus 1. So this cannot be 0. So we look at this x plus 1 equals 0. X cannot be -1. So let's look at our domain that we're considering using, the 3 to infinity. 3 to infinity. Is -1 in this interval? Nope, it's not. So this would be the domain we would use for our f of g of x. That domain works perfectly fine because the number from the denominator to be excluded is not in this interval. Last example, remember here we switched up the denominators. So now the denominator we have to consider is this square root x minus 3. This cannot be equal to 0. X minus 3 cannot be equal to 0. So x cannot be, 3 cannot be included in our domain because it would create a 0 in the denominator. So if we look here, this is the domain. When we looked at f and we looked at g individually, we said this is the interval that works for the both of them. In this case, we were able to leave this bracket because the -1 that we had to exclude because this denominator situation wasn't in here. However, in this situation, the 3 can no longer be included because it creates a 0. So a 0 in the denominator. So what happens here is this bracket now has to become a parentheses because the 3 can no longer be included because we've created a fraction here. And that fraction has a denominator where 3 would cause an undefined situation.